Well, hello and welcome to everybody to this webinar about the biggest eggs mistake. This is one of the many topics that we cover during this kind of events, and considering the good feedback that we are receiving from the participant, we are continuing sharing our knowledge about intrinsic safety and functional safety. Just a brief introduction about myself. I'm Gabriele Caglio. I'm the technical support specialist here in GMI. And then we have Bob Johnson, which is the expert and today's main speaker. And there we are.
There we go.
Something about GMI. I would like to start with this for whom doesn't know us. GMI is an Italian company providing field devices related to intrinsic safety and functional safety. This means that it is possible to find GMI devices in many industrial packages such as DCS, CSD, fire and gas, and so on. As you can see on the screen, we are talking about oil and gas, pharmaceutical, petrochemical, mining, but also food and beverage and many other industries. We have 40 years of experience in the field. The headquarters is in Italy, where we have our main facility, and where we design, we produce, and we test all our products. As I said, our main office, as I said, is in Italy, but we have offices all around the globe and resellers, so we are available pretty much everywhere. As I mentioned before, we are a safety company, and we aim to provide safety to reduce risk of hazardous events and safeguard people, assets, infrastructure, production processes, and the environment too. For this reason, the quality aspect of our product cannot be overlooked. We design our product, we manufacture and test 100% our device internally, meaning that we do not outsource any of these tasks. What we see here on the screen right now, and probably one of the last things I can tell you today, is the portfolio. Introduce a little bit our products. As I mentioned, we have intrinsically safe barriers, safety relays, certified, seal certified, with and without line monitoring for energized to safe or de-energized to safe application. We have isolators, AX power supply systems up to seal 3. We have temperature and digital multiplexers for zone 1 installation. We also have customized termination board for an easy connection to the main PLC and DCS systems. We have hard multiplexers, surge arrestor. We also provide consultancy and share our expertise through courses related to functional safety and intrinsic safety. This last slide is about our resellers, just some of them from system vendors, EPC, OEM, and end users. And that's all about the presentation of the company. I just want to give you just 2 more information about this webinar. It's being recorded. It's going to be soon available on our YouTube channel. You're going to receive a PDF presentation in a couple of days from now, and you will also get a certificate if you attend at least 75% of the webinar. And as you know, if you have any question during the presentation, please write down in the Q&A session, and we will try to answer. So now I think that, Bob, they're all yours.
All right. Well, Gabriele, I appreciate it. And I don't know if you want to go ahead and continue to control. If it sounds like most people can see it. It looks like I can control one of your screens. So let's see if
you
that
can control the screen now.
Don't think I can control. Well, let's see. Doesn't want to.
Yes.
Oh, there it goes. It just got delayed a little bit. Okay. Well, thank you very much for participating in this. And this is always an interesting topic because this is more my opinion and based upon my experiences. So don't necessarily take this as the end all be all, because you may have different experiences. But these are things that I have found over the years of doing inspections and working with various companies over the years, as far as what we see in problems, working with certification bodies. I've been in the EX business for over 35 years now. A lot of what I've done up until probably about 25 years ago was more around North American standards, and then really been involved much more in the international side of things, or at least international for us here in the United States, more around IEC and ATEX and all that good stuff. So that's primarily what we're going to be talking about. I know we had one question that came up from one of the pre-registered people, was talking about, is this going to be more on the international side, or is it going to be somewhat on domestic US? This is truly going to be much more on the international side, but some of this stuff also applies for US applications. So it's something that we do run into the same problems, because in many cases, the EX concepts and everything else are fairly similar. We just call it different things. But anyway, one of the things I wanted to highlight, and this is, I know we have a lot of engineers that are on board here. And, you know, as an engineer myself, we think of, typically it's not the engineering fault that problems arise in the EX world. But in reality, if you look at this particular slide, the root causes of a lot of mistakes that are made, or industrial accidents, and this was put out by the HSE quite a few years ago, actually comes down to specifications. And I think we all could probably agree with this, is that if we're a supplier of EX equipment, or if we're an engineering firm working for a firm, that we're trying to meet their specifications, meet the regulations, meet the standards. And of course, in many cases, some companies will put everything but the kitchen sink, so to speak, into their specifications. There's a lot of conflicts in many cases between standards and regulations. And so we try to pick and choose and kind of hopefully get the right thing done. But still, it results in many cases, a lot of the problems get traced back to actually at the specification level. So the important thing to note is that this isn't just an operational issue. It's not just a construction issue. This is something that it doesn't matter how good those people in the field are when it comes to actually doing installations. If we get it wrong at the very early stages, unfortunately, we really can't correct it at a later date until it's almost too late. So be aware of that. It's one of those things that, again, a lot of the problems I see actually come from very, very early on. And we want to make sure we catch those errors before it actually gets into the construction phase or operational phase. So how do we define mistakes, right? So fortunately, you know, what do we use as a tool to kind of identify all of the potential pitfalls and problems that we could see with EX equipment? And fortunately, we have a bunch of standards that we can kind of follow, but the 60079-17 standard is really kind of the go-to, if you will, because this is an inspection standard. So any piece of EX equipment that gets put into service, the requirement based upon the 17 standard is that you have to do an initial detailed inspection on this particular piece of equipment. So that's where we typically find these mistakes, is usually at the very last moment before it gets deployed. We want to try to catch those mistakes, however, before we get to this stage, because this is always, again, when equipment is ready to be installed, it's at the last moment, we're ready to ship this equipment, or we're ready to energize it. We don't want to have these kinds of issues at this particular point in time. The good thing is that pretty much around the world, regardless if you're in Europe or in the international world or in the United States, Canada, anywhere in the world, we pretty much follow these same standard in a variation. Even in the United States, we have published a UL 60079-17 inspection standard. Now, this only applies to zone-rated equipment, but we also are publishing currently, or working on, a new UL standard for inspection of division-rated equipment. So that's something that's forthcoming here that you're going to find. So a little bit about what the inspection templates, if you will, if you have not seen what they look like out of 17, this is kind of what they look like, if you will. There are inspection tables for various protection concepts, and we use these to go ahead and check out. Now, an EX inspection is different than a traditional FAT or something of that nature, where an EX inspection, what we're really trying to find is whether or not the equipment is a potential ignition source. When I'm going in and doing an inspection, I don't really care whether or not the equipment works. That's secondary to me. I mean, if it doesn't work, hey, it doesn't work. As long as it's not an ignition source, my job is okay, but that's not necessarily what you really are wanting to do. You want to make sure, obviously, the equipment is operational. Not only that, but you want to make sure that obviously it's safe to be used in a hazardous location. So the important thing to note on this too is it just the inspectors that need to know this? In reality, I tell people, no, it really should be something that everybody should understand, because this makes life so much easier, especially if you're building skid packages or you're responsible for the design of these packages. You want to know what the inspectors are going to be looking at so you can anticipate that and maybe actually do your own inspections and catch all of these mistakes before they actually get caught by your client or another third party or something like that. So it's broken down into visual, close, and detailed inspections. And typically these initial inspections that we do are always what is called a detailed inspection, meaning that we're opening up the equipment, we're looking inside, we're looking outside. We expect that the individual that's doing this should have an electrical background, but there's also ongoing inspections that we do from a maintenance perspective that we can do either a visual or close inspection where we're just literally looking at a product and looking for obvious damage. So that's more of an ongoing type situation. So what's one of the biggest mistakes I see? Okay, and this is one that's it gets overlooked, or I shouldn't say it gets overlooked, but it's pretty obvious that we would think, hey, this is a we should all catch this, right? But invariably, I've seen this so many times where the equipment is not suitable for either the zone, the gas group, the temperature code, or the ambient. And a lot of that information doesn't necessarily get relayed early on a project scope. So therefore, a manufacturer is trying to comply with it and they're guessing. So we want to make sure if we're responsible for writing these specifications, we need to make sure that we get this information out to our vendors, make it very clear. What is it about this particular equipment? Where's it going? Is there a minimum IP requirement? Is there particular environmental conditions? One of the things that I see a lot, ambient. The standard product ambient is -20 to +40. If equipment is not marked, that's what the default is. But in many parts of the world, either, up north where it gets really cold, -20, it can get down to -30. +40 degrees, it'll be above +40 degrees here in Houston this afternoon. So if I've got a project in the Gulf of Mexico or anywhere in South America, +40 is just not going to cut it. So we have to pay attention to that as well. And then, of course, what is the certification required? Is it IEC EX? Is it ATEX? Is it some other certification? So just looking at some different examples, right? If this particular piece of equipment, the requirement was zone 1, 2C, T6, requiring a +50 degrees C and an IP65 and an IEC EX certification, by looking at the label, what can we see there that's basically telling us, hey, this is a problem? Well, there's a couple things. Number one, we don't have a +50 degrees C rating on this. We're okay from a T code, we're okay from a gas group, we're okay from a zone, and we understand that based upon the marking strings associated with this particular piece of equipment. The other thing is that this is only ATEX, and we know that based upon the markings of the EX and the hexagon and the CE mark, and there would actually also be an ATEX certificate number on this label. If it had an IEC EX, it would be marked with an IEC EX certificate, and this particular product doesn't have it. So in this particular instance, if I'm going out there and I'm doing an inspection, immediately I would say, hey, this thing has to be removed. We cannot use it for this application. Find a replacement. Looking at another label, again, using the same basis, Zone 1, 2, CT6 +50 degrees, IP65, again, needing IEC EX certification. There's a couple issues here. Actually, ATEX is the main issue. We don't have IEC-EX on this. We're suitable for the zone. We're suitable for the gas group. We're suitable for the ambient temperature, and we're suitable for the temperature code. But again, in this particular instance, it's not certified correctly for the application. In this particular instance, again, using the same basis for our project, the issue is that this product has got a couple issues. Number one, it's only suitable for Zone 2 applications based upon the protection concepts. It's only suitable for a 2B application, not 2C. The big thing is, in this particular instance, this is a component certified product, and we know that because there's a U at the end of the certificate number. That means this product cannot be installed as a complete assembly. It's part of something else. So therefore, if I see this is again a product that would have to be removed, or it'd have to undergo some sort of field evaluation and recertification. So again, we want to stay away from this and not use it unless it's part of an overall assembly that's going to be certified as a complete assembly. Another hint, by the way, when you see a product that doesn't have a T code, such as this one, that means it's generally going to be a component certified product. We don't assign it a T code because we don't know exactly how this is going to be installed, because it's going to be part of something else. It may have some other components right next to it. Therefore, the T code is really not something that we would put on this product based upon the fact that it is a component. And then on this one, again, we need to look very closely here, but we have some issues. In this case, it's not suitable for 2C applications. It's not suitable for T6. It does have an IEC-EX certification. It does meet IP65. It does meet plus 50, but we have 2 strikes against it. So in this case, again, we could not use this particular product. So these are all examples of products that, could be selected, installed, and everything else. And at the last minute, we literally say, hey, look, this is not suitable for the environment. And this is a pretty common mistake. And this is something that, again, no amount of technicians that are in the field that are doing installations could fix these issues. This is something that's done very early on during the selection of the products. So we have to be very, very, very much aware of what are our parameters of what we need to comply with, and making sure that our products are going to be suitable for that before we actually even start getting into installation and construction. And then this is just one last one. Again, no IEC-EX certification. In this case, it's got ATEX. It has a U certificate. It's a component. So again, we could not use this. And I do have another one here. This is ATEX only. This has NA. It's Zone 2 only. So again, we would not be able to use this for a couple of different reasons. So these are the things that we need to, again, take a close look at. I've got another one, another Zone 2 product. This IP rating would not meet the requirements as well. So you can see it's important to understand these labels and you're going to find all this information obviously in the data sheet from the equipment and ultimately off the certificates. And that's really an important thing that I would emphasize to any engineers, designers out there. Before you actually buy anything, make sure you get copies of certificates, because there's a lot of information in there that will tell you certain things. And actually, it's going to be a mistake that I'm going to cover here in just a minute. So what is the relevant standard for inspections of EX equipment and installations? I don't know if you can bring up, Gabrielle, the poll or not, but we can skip that.
Take the control.
I can just give the answer.
Okay, yes. I always wanted to check if there was some question.
No worries. We can skip that. I'll just give the answer. It is the 60079-17 standard. So that's our inspection and maintenance standard. That's the one where we're going to find the inspection tables. The other standard that is relevant, that's important for a lot of people to understand, is the 14 standard. That standard is our design and installation standard. And we will find inspection tables also within 14. But really 17 is the main standard that we really want to focus our attention on. and make sure that that's something that we use. When we do inspections, we actually have a lot of those templates, if you will, already built into either software programs, and there's many different inspection software programs that are commercially available. But in many cases, we still use pen and paper. We use Excel spreadsheets, and we fill those check sheets out with all this information, and that's part of our final inspection as well. So moving on, let's look at, if I can get this to move. Oh, I don't know if it's doing anything. Ah, I did move. There we go. Mistake number 2, second biggest mistake. Modifications into EX equipment outside of what is allowed. And one of the things that I see an awful lot of is additional entries drilled into EXD enclosures. That is a no-no. It cannot be done in the field. It can only be done by the manufacturer. The other thing, additional components installed in an enclosure, and this would apply not necessarily just to EXD enclosures, but it also applies to other EX enclosures, because when we get them certified with a certain set of components on the inside, we're assuming that those are going to be the components that are going to be used, and we're going to have to develop a temperature code based upon this. Well, if we take and all of a sudden add an additional power supply, or we add an additional contactor on the inside of an enclosure, that's going to generate more heat, which therefore is basically potentially going to violate our temperature code requirement. And also, depending on the placement of this equipment on the inside of a, for example, EXD enclosure, we could introduce what is called pressure piling, which is a situation in which we have an explosion on the inside of a flame-proof box, but because of the orientation of the components on the inside, we're blocking, if you will, an explosion from taking place and actually creating a potential secondary explosion, which can be that much greater than the first explosion. So we need to be very careful about adding and modifying things in the field. Additional items such as O-rings, Teflon tape, labels even to existing equipment. Adding labels is always an interesting one, because people say, well, you know, I just want to add my tags. I want to add my labels to pieces of EX equipment. You have to be careful with that in the standpoint that you don't want to do anything that's not allowed by the manufacturer. I've seen times where people have taken EXE boxes and they'll go ahead and just drill a hole, a pilot hole through it, and then they'll take rivets and do everything. But if it's not been installed in accordance to the manufacturer's recommendations or documentation, you might be potentially violating the ingress protection requirements. Certainly, if we're drilling into a flame-proof box, we have to be extremely careful, and we don't typically want to do that. We want to have the manufacturer go ahead and drill us maybe pilot holes, so we can, after we receive the enclosure, we want to install a label to it, then we can do that in the field. But we don't want to be drilling these boxes in the field. Things like Teflon tape around glands, flame paths, those impede the flame path, even though people think, hey, this is a great idea to maintain a higher ingress water protection. But Teflon tape actually will impede on a flame path. So we don't want to use any Teflon tape on any flame path. So these are the kinds of things that, again, are pretty common that we see. And there's an example there on the right-hand side. Well, we've got, you know, basically a couple IP washers. We have a tapered thread, and that actually very well could be okay on the right-hand side. But then on the left-hand side, that looks like that's an increased safety junction box. And for example, there are minimum or maximum lengths of cable. It looks like we might have a combination of intrinsic safety and increased safety within a one enclosure. But when we're doing all these bundles, we could have heat buildup. We also have potential issues with segregation of keeping IS away from non-IS circuits, which is another issue that we'll talk about here just a little bit. Looking at our next slide, if I can get this thing to work. Oh, there we go, Teflon tape, or not Teflon tape. Now we look at this particular one and we say, hey, it all looks good. Everything looks fine. However, just by looking at this, those particular glands are not barrier glands. And that may or may not be an issue. So we have to understand, this is a flame-proof panel. What type of cable is being used? What is the length of cable? What is the requirement under the Dash 14 standard with regards to the type of cable, and whether or not we have to use a barrier gland or a non-barrier gland? We don't know that just by looking at this panel right now. We need to know further as far as the length of cable, the types of cable, to determine whether or not those flame-proof glands are acceptable. So again, just by looking at it right now, hey, it looks fine, but we're not really 100% sure until we truly look closer at the details. This is an example of kind of a very obscure one, and you might be able to see this. The label on the top, if you notice, excuse me, what's circled there, that says EXDB, and then in brackets it says IA. On the panel below, it's an EXD with no IA. So the panel above is a panel, a flame-proof enclosure in which we actually have associated apparatus such as intrinsically safe barriers mounted inside. And that's allowed based upon the certificate of that enclosure. If I look at the label on the product below, it does not say that. So if I open up that panel right there, I could open it up, and if I see maybe an associated apparatus like a GMI barrier, I'd say, hey, wait a minute, is this actually approved for use on the inside of this panel? And generally speaking, because it's not marked with a bracket IA as associated apparatus output, I'd say, hey, no, this is not right. We'd have to reevaluate it, potentially recertify this panel. So these are little things that you really have to key in on sometimes. And again, they can kind of trip you up. We want to make sure that we catch this stuff before we start buying things and specifying things. There's an example on the left-hand side where we might have a shroud that's covering up a cable gland that's got Teflon tape. On the right-hand side, we have a combination of some EXE stopping plugs and non-EXE stopping plugs. So again, the non-EXE stopping plugs would be an issue. The Teflon tape is an issue. We definitely do not want that. And by the way, one thing about shrouds, a lot of people, this is more of an opinion, right? I would highly recommend against using cable shrouds, because cable shrouds have a tendency to hold the moisture in against the cable gland. And what will actually happen is that it holds that moisture in, and it'll start eating away at that gland. And so you'll actually accelerate the corrosion, if you will, that'll take place in a marine environment, for example. So typically a lot of clients have gotten away from using shrouds. The other thing is, and people don't think about, but if I've got to do an inspection on that, I'm going to have to check and make sure that that gland is appropriate. So what am I going to have to do with the shroud? I'm going to have to either cut it or try to slide it back. And in many cases, it's very, very difficult to do. So again, highly recommend against using shrouds. If you use a high quality cable gland that has a good IP rating and ingress protection rating, then cable shrouds are really just not, they don't do the job. Mistake number 3. This does come into a lot of installation details. So non-certified glands, improper installation of glands, not using the appropriate accessories, maybe using EXE equipment accessories and EXD enclosures, failing to take note of special conditions for safe use, using stopping plugs within reducer fittings, or using multiple reducer fittings. So these are all issues that we want to try to stay away from. So on the left-hand side, you see a gland that's not been properly installed. We see the armor. It looks like the clamping ring is not secured very well. We also see damage to the cable, and that's coming from what is called cold flow. That's an overcompression, if you will, of the inner bedding. We want to take note of that. We don't want to have a gland that's overcompressing on the inside, because that will ultimately damage the cable. On the right-hand side, you see a transmitter with a little red stopping plug. So that's a traveling plug that should have been removed during the installation and replaced with a certified stopping plug. So those are not too uncommon. We see stopping plugs like that on a lot of equipment. Fortunately, that's an easy fix. There's also a situation over here where we see on the right-hand side, we see a transmitter with some plastic glands that looks like it's an EXD enclosure, and it probably is. So therefore, plastic glands would be a no-no. We would have to replace those glands. And then what we have over on the left-hand side, we have an elbow fitting, which is okay to use, but now we have a bunch of adapters going in between. So we're really not allowed to use an adapter and a gland and an elbow. We want to minimize that to an extent. So we've got quite a few fittings that are all right there. So we probably want to find a little bit better, more elegant solution than what's come up here. In this case, on the left-hand side, those are stopper boxes, or what we call here in the United States seal fittings, and obviously have not been installed properly, if you're familiar with those. So they actually require them to be packed with a compound, a cement-type compound that cures around the individual cores, and they obviously have not done that. And then obviously a cable that is pulling out of a cable gland. So again, these are definitely some installation issues. Here's some other installation issues where on the left-hand side, that's the inside of a flame-proof enclosure where they've taken some of the packing material for barrier glands and just came in from the inside and actually used a combination of two different manufacturers' compound to try to pack it sufficiently. So there's quite a few issues there. On the right-hand side, it's difficult to tell, but it looks like the IP washer is a little bit too big for the particular gland on the far right-hand side. So it's not going to provide you any really good protection at that particular point. So again, some of these are pretty minor. You know, they don't necessarily pop out at you, but these are the things that you want to be looking at. Obviously, left-hand side, the gland is pulled out. On the right-hand side, we basically have not landed the armor on the inside of the glands. So those are definitely some issues. And then looking further at some other ones, again, on the right-hand side, we have a shroud that's covering up the steel wired armor that's coming out. On the left-hand side, actually, I'm not really 100% sure what the problem is with that one. It looks as if everything is okay. We have IP washer in the appropriate place. We have an earth tag. It looks like we have some sort of adapter that's going in there as well. So it may be a situation where maybe we should put an IP washer in between the earth tag and the adapter. But in reality, I think that's actually an okay situation. And again, some other things, some other glands. These are just, you know, some real world pictures that you would see. And then, of course, barrier glands in which the compound isn't properly cured, or maybe the internal seals get torn. These are all kind of examples. And this is one that you see sometimes. We'll have maybe a barrier gland on the right-hand side and a non-barrier gland on the left-hand side going into the same enclosure. Is that a mistake? It may or may not be. It really depends on the length of cable based upon the latest edition of the 60079-14. The rule of thumb is that if we're going into a flame-proof box and the length of cable is less than 3 meters long, then a barrier gland is required. If the cable, on the other hand, meets all the requirements of the standard, which are round, circular, compact, extruded bedding, and no fillers, and the cable length is longer than 3 meters, then we can go with a non-barrier gland like the one on the left-hand side. So this installation actually is correct, but we wouldn't know that necessarily until we looked at the length of cable in this installation and understanding what type of cable is actually being used. Just ask this question: can you use an EX certified stopping plug in conjunction with an EX certified reducer fitting on an EXD enclosure? So here's where we're taking a stopping plug. Maybe we have a hole in a flame-proof box that's, let's just say it's an M32. And I have an M20 stopping plug. I don't have an M32 stopping plug, but I have an M32 to M20 reducer, and I'll use that, and then I'll put a stopping plug into that. Is that acceptable? The answer is no. I cannot take on flame-proof boxes, I cannot take a reducer and a stopping plug and combine them. I can take a reducer adapter with a cable gland, but if I ever use a plug, the plug needs to be the actual size of the hole of the enclosure. This is something we see quite a bit of times. Let's continue on here. Controlling your computer from Houston, Texas. Trying to do it here. Come on. Here we go. Intrinsic safety, the mistakes on IS. There's quite a few on IS if we get into IS. No segregation between IS and non-IS, no label indicating IS circuits, improper grounding of IS. There is no descriptive system document. There's failure to select certified equipment where it's required. For example, we can use what are called non-simple devices in IS circuits all the time. They do not require certification, but if the device is energy storing, then it has to be a certified device. And then modifications to design after the installation, substitution of different barriers, or maybe we're increasing the cable length. Those are all issues with intrinsic safety that we need to be concerned with. So what you see on the left-hand side there, again, we have, it looks like a combination of intrinsic safety and non-intrinsic safety. We had a partition, we had IS over on the right-hand side and non-IS, but unfortunately, when they did the installation, they combined all the cables together. So we have defeated that segregation requirement. The same thing holds true on the right-hand side where we may have our outgoing is IS and our incoming is at the top, but we've done a service loop on the inside of this panel, and now all of a sudden we're creating all kinds of problems. So we need to maintain a 50 mil separation between IS and non-IS on the inside of our panels. So we can do that either by distance, we can do that by partitions, or if one or more of the cables are shielded, we can do it that way as well. But that's definitely, in this case, these are just non-shielded conductors that are running on the inside of panels. And there you see those. On the left-hand side, again, we're running into that 50 mil separation. The same thing holds true on the right-hand side. We have a segregation there between IS and non-IS, but we've somewhat defeated that because of the way that we run these cables outside the output out of the barriers themselves. Mistake number 5. This is one, and we kind of talked about it a little bit. This is a U certified box. So somebody buys an empty terminal box and they get it and it comes in with a U, meaning it is a component. And then they go ahead and install some terminal blocks into it and they assume everything is A-OK. The problem is the label, and I realize that label is very difficult to see there, but there's a U at the end of the certificate number and there's no temperature code. So therefore, this product would not be acceptable, even though they use the exact same terminals that the manufacturer would have used, and they installed it correctly. There's no real problems with this, other than it's not certified as an assembly. It's only certified as a component. So this is something that we want to make sure that when we're specifying or using things like increased safety, we want to make sure that we get them as a complete assembly and not just an empty enclosure and just think that we can populate it ourselves and away we go, because that's typically not the case. This is another example of 2 small little flame-proof boxes that are basically the same part number, but the one on the left-hand side is actually a component certified product. The one on the right-hand side is the same box, except it has terminals. So the right-hand side will actually have a temperature code. It will have a certificate number without a U. The one on the left-hand side, notice it does not have a temperature code and it has a U. So that's an empty enclosure on the left-hand side. The one on the right-hand side has terminals. So if we were using this box as a pull box, if you will, just not having to put any terminals in it, we could use a U certified box for that application. But if we were to land any terminals on the inside of this enclosure, that U certified box would be rejected. Conditions for safe use, because I mentioned there's a U certificate and there's an X certificate. X certificate means, or actually, this is a different one. We'll skip this, what I was going to talk about. Improper wiring techniques. Unused terminal blocks are all supposed to be tightened. Too much copper showing on connection points inside of EXE enclosures. Undersized earthing conductors. Using cables with non-barrier EXD glands for installation on EXD enclosures that do not have the cable construction that meets the requirements. So, you know, on the left-hand side there, we see some conductors that are going into some GMI barriers, but obviously they're not landed very well. We have stranding there, and that's not what we want to see. And then lack of proper maintenance on EX equipment. Obviously, the one on the left-hand side, that's a flame-proof box with all the bolts missing. Somebody didn't realize exactly what the importance was of all these bolts with a flame-proof box. They just put some baling wire to close it for a temporary period of time and never replaced the bolts. On the left-hand or on the right-hand side, it looks like they've got a little bit of corrosion going on with this particular enclosure, and we'd want to make sure that the enclosure, the flame paths, are still intact and in good shape. And obviously, where we have things like water ingress, we want to make sure that we address that. On the right-hand side, we have a broken gland. So again, we have to be aware of that. And that was covered up by a shroud, right? We can't really tell a lot of times if a gland is broken or not until we actually remove the shroud, and then we find that there's problems. That's another reason why I don't like shrouds, because we can't see the problems. And our last mistake, earthing of intrinsically safe Zener barriers. I did an inspection here about a month or so ago in which they had some Zener barriers on a marine vessel, and on a marine vessel, as you might imagine, trying to find clean earth on a ship is very difficult. You typically would not find any clean earth, and they tied it into the earth point that was marked as clean earth that was literally about 1 meter away from the dirty earth, tied into each other by a metal plate. So there was no clean earth. So Zener barriers do require a clean earth, and so we have to be very, very careful when we're using Zener barriers in particular that we maintain and have a clean earth. That's one reason, actually, if people ask why GMI does not offer Zener barriers, is because of that fact. Galvanically isolated barriers are truly a safer methodology. They cost a little bit more, but it is a safer product because we do not require that clean earth. And the reason why they cost a little bit more is that now you actually have to have some sort of transformer on the inside of these barriers to replicate the signal going from the safe area to the output to the hazardous area. So that's one of the things that you see. Again, the downside of a galvanic is they do cost a little bit more, but the upside is you don't have to worry about the clean earth. And that's a big issue. So what letter will signify as a component certificate? That's going to be a U. So if we see a U at the end of a certificate number, we know that it's a component. If we see an X at the end of the certificate, there is some sort of condition for safe use. And we definitely want to look at that because that's something that's telling us if we want to apply this product, we need to make sure that it's installed in accordance to whatever those conditions are. I'll give you one example, cable glands. In many cases, cable glands will have an X condition, meaning they're suitable for fixed installations, meaning I can't just put it on a portable piece of equipment. But there's another X condition that applies to certain glands as well. It may require a clamping within 300 millimeters of the back end of the gland to provide strain relief. Now, not all glands have that, and it's not necessarily with all cable types. If you don't know that and you go ahead and do an installation and somebody comes along and looks at the X condition and says, hey, you've got 100 glands here that are installed or 200 glands, and you didn't follow the X condition and you need to clamp this, In many cases, it could be very simple. I could put a cable tie of some sort of stainless steel band or something, attach it to the structure. But what if there's no structure? So now all of a sudden I have to take some strut or welded steel or something like that and actually build a structure to be able to clamp it in some way, shape, or form. So those are the kinds of things that we want to pay attention to before we get into the construction phase. So to kind of summarize here, we do have some Q&A questions. Mistakes can happen at any point, right? It's not just the installation or the installers and the operators. It's again, it can be done at the engineering level, and we need to make sure that we catch those early on, right? These are just some of the ones that I've seen, and I'm sure there's some other ones that you've probably seen or you've experienced in your own work. But the important thing is that we want to do everything we can collectively, no matter what our role and responsibility in the EX chain, is that if we have a breakdown anywhere within this chain, either at the engineering level, procurement level, installation level, management level, then we could have a potential dangerous situation. And we don't want to have that. We don't want to have loss of life, loss of property, because this is a safety critical issue and it's a safety critical industry. So we want to catch those errors, right? All right. Gabrielle, you want to put up the Q&A real
Yes,
quick?
let me stop sharing for a moment.
You there?
Yes, stop share. Now I wanted to check if we have.
If you don't have it, I think I have it.
No, I have it. We have something in the Q&A, but no, it's still people that are hearing or not hearing us, but everybody seems good now. Yes. And
There was one question that's come in while you get that going. In IEC EX, simple devices like an RTD or a thermocouple that has North American XP marking, can we change the terminal blocks with IEC EX approval, or does putting IS barrier works? Is there other options? So if I have a simple device, here's one of the, as a simple device, a thermocouple, a lot of times we'll put those in a box that will be, maybe a US certified explosion proof box or something like that, or internationally approved flame proof box. In reality, what I would suggest in that scenario is actually it's not required to be an explosion proof or flame proof box if it's being protected by intrinsically safe barrier. A barrier would work for that application, but what we would want to do is put a label over, if you will, the EX label on it to say something to the effect of, this is a simple device being protected by intrinsically safe with well-defined parameters. And that will make an inspector say, okay, great. I don't have to worry about the fact that this is a U certified box or even a flame proof or an explosion proof box. So I'm using it in conjunction with intrinsic safety. So therefore, simple device does not require flame proof or explosion proof. It just requires a housing. So therefore, by putting that label on there, that's going to take care of it. So some of the questions came up. Difference between flame proof and increased safety for applications. This comes up an awful lot. Let's see if I can get this to move. Yeah, here we go. So here's the main key differences on one versus the other, right? Flame proof allows ignition capable equipment to be used in a hazardous location. So I can put contactors, relays, printed circuit boards, all different kinds of arcing devices, general purpose rated type devices in hazardous area. On increased safety, I'm limited to basically anything that's non-ignition capable. So the big application for increased safety is terminals and terminal blocks. However, there are other devices out there that are non-ignition capable and they're certified in and of themselves and have an EX certification that we can install on the inside of increased safety enclosures. But we have to be wary of that in the standpoint, we can't just take those devices and stick them on the inside of these boxes unless the enclosure allows you under its existing certification to do that. So you don't want to just take maybe an encapsulated relay or some sort of or you see switches and pilot lights and operators. You don't want to just start punching holes and putting them on the inside of increased safety enclosures because it's not certified for those operators. You have to double check and make sure that that's allowed. And again, in those cases, you can certainly find increased safety boxes where operators and various other devices are readily available, but you just can't necessarily do it yourself. Again, on Flameproof, we can put all kinds of ignition capable equipment inside, increase safety, we just cannot. That's our big problem. Why must we use EX equipment near industrial furnaces which have a source of an open flame? It's an interesting question. Yeah. So we assume the area classification documentation requires EX equipment near the open flame source, but the source of release is far enough from the open flame and would potentially be below the lower flammable limit once it gets closer to the open flame. So there must be some ventilation of some sort, or maybe it could be natural ventilation or artificial extracting. So we could have fans that are drawing any potential flammable gases and vapors away from that. We may be also required to have a gas-free permit or gas sensors nearby the furnace to make sure that it's monitoring at all times, and they're set for usually about 20% of the lower flammable limit of the potential gas vapor potentially being released into the environment. But that's how we would address that. Expiration date of flameproof equipment. I won't go back, but that was the question. And I've never had that question before, but it's actually an interesting one. Generally speaking, once flameproof equipment is put into service, and this is true really for all equipment, EX equipment, once it's placed into service, as long as it is still functioning and it's still in good working condition, and there's no obvious mechanical or corrosion or water ingress or something like that, we can use this equipment for the life of a project. So there's certain materials that usually lend itself better. So things like, a 316 stainless steel enclosure is typically going to hold up better in a marine environment than maybe a marine grade aluminum. So you're going to get a longer lifespan out of that. But generally speaking, if you maintain it, and you keep it clean and you lubricate the flame pass when you do a detailed inspection on it, you should get, 20, 30 years lifespan. Again, assuming that the corrosive environment is not so bad, you should get a long amount of service with it. And the key is preventative maintenance with these, right? It's just like, changing the oil in your engine. You want to make sure you do that. If you don't, then your car is going to break down much sooner. When selecting EX equipment, where should I find the relevant information as to installation instructions? So the manufacturer's data sheets is certainly important, and it's also advisable to obtain the copies of the EX certificates from the manufacturer, because that's where you're going to find the certificates of safe use, if they exist, and it will have any limitations associated with that particular product. So that's important to understand. And again, certainly following the requirements of 60079-14 from an installation and design standpoint is critical. That's not the only design standard, however, you need to be aware of, is depending on the markets that you're going into. If you're in the marine business, you may also have to comply with the IEC 60092 set of standards. If you're going into the mobile offshore drilling unit market, you'll have to comply with the IEC 61892 set of standards. Or depending on where you're going in the world, you may have to follow API recommended practices or a variation of the IEC standards. So it's always important to understand. The other thing about the standards as well that I always emphasize this, the standards are a minimum requirement. So the standards will tell you, hey, you do this, you're okay. But in many cases, companies will go above and beyond, and they'll require additional, they'll go above and beyond what's actually in the standards. So first and foremost, you really have to pay particular attention to whatever the project specifications are. We have a couple more here. I know we run just a little bit long here. How to properly wire our screens. They are usually earthed at one point, normally at the non-hazardous end of the circuit. It's required to avoid the possibility of the screen carrying an incentive level of circulating current. So this is typically what you would see with grounding of IS circuits, if you will. And again, we'll give you a copy of this presentation, and this will be online here shortly to where you can rewatch this. EXD enclosures with removable gland plates. Is there such an animal? I have yet to see an EXD box with removable gland plates, but EXE boxes certainly have them. And EXE boxes, the whole purpose of a removable gland plate is to make it easier to punch holes. And we can punch holes on EXE enclosures. So the idea is here is that if we screw up, then we only have to replace the gland plate as opposed to having to replace the enclosure, the entire enclosure. So what are the relevant standards used for EX equipment used worldwide? I think I've mentioned this a couple times, but the 60079 set of standards is really the key one to follow. Pretty much everywhere in the world now uses the 60079 standards. Those apply to electrical equipment, but there's also new ISO IEC 80079 standards that apply to mechanical equipment. So if we're dealing with mechanical equipment in hazardous locations, these are the relevant standards you want to take a closer look at. And again, as I mentioned, the 61892 for mobile offshore drilling units, for the marine business, the 60092 standards. And again, there are some other ones around the world, such as the National Electric Code, the NFPA 70, the Canadian Electric Code, BS 7671 will have some information on hazardous locations. NEK standards, NORSOC, there's a bunch of different ones out there that you need to kind of pay attention to. Can I install a barrier in the field in a remote area? Yes, absolutely. We can take barriers and install them. In many cases, barriers are rated for Zone 2, and we can actually install them in a sheet metal box. But if we say we need to install it in a Zone 1, then we could take those barriers, install them in, say, a flame-proof enclosure or potentially a pressurized enclosure. So yeah, you certainly can do this. And this is true in the US as well as in the international world. Small pumps or heaters rated at approximately 300 watts. Should the power supply box switch be EXE or EXD? This was, again, another interesting question. Hadn't really seen something like this, but generally, again, anything that is ignition capable. So whatever's going inside that box would require the use. If it is ignition capable, we really have to go with an EXD box of the two. If the power supply, however, is rated EX, then the enclosure would be rated EC, and the overall assembly be rated for Zone 2. So we could get power supplies and put those in a Zone 2 area in a sheet metal box inside, in effect, an EC enclosure. So we are limited with regards to increased safety with what we can put inside, but there are certain devices that are rated for hazardous locations that we can find and use. And so that is certainly an option. But we really have to look at our power supply or the switch or the field device or that device that we want to put inside to confirm that it actually has a certification. And hazardous area protection most widely used. Well, that's a tough question. High power, typically it's usually EXD or possibly pressurization. If it's low power, it's almost a lot of intrinsically safe, but we don't have to use IS. When we get into Zone 0, we're pretty much limited to intrinsic safety or encapsulation. You get into large high voltage equipment, it might be oil immersed. So there's multiple different ways to look at it. The marketplace is definitely trying to get away from flame proof as much as possible and try to use other techniques, increased safety being one, or a combination of increased safety enclosures with flame proof components. That's certainly a great way to go. It's usually lighter, faster, cheaper. So, but in some cases, we're just limited to going with full flame proof. So that's mine. I ran a little long. I know we started a little late, but
Yes, that was my fault.
it's me.
I can admit that.
No worries. Not on my behalf. So anyway, hopefully this was of interest to you guys. We will have this published here shortly. And again, if you hung around, we captured your name and all that good stuff. You'll get a certificate. I think if you lasted for more than 75% of this.
Yes.
So we sent those out. And but if you do have questions on EX and then we didn't address it today, please feel free to reach out to me. My email address is bob.johnson@sourceiex.com, or you can reach me at bob.johnson@GM. I can't remember what it is, my GM International email.
GMinternational.com, yes.
Yeah, gminternational.com. You can send it there or the other way. So either way, but if you do have questions or if there's something that I can help you with, that is, you're running into something, feel free to reach out to me. I'll be happy to try to kind of steer you in the right direction.
And also, if you have any other question about the webinars and so on, there is an email communication@gminternational.com. If you have any other doubt, I just want to check if we have any other question. Yes, in the Q&A. Do we have a minute, Bob, to answer this question?
Yeah, absolutely.
I can read out loud, so then you can answer. In
Okay.
ICAX, simple devices like RTD or thermocouple that has North American XP marking. Can we change the terminal box with ICAX approved, or does putting IS barrier works?
On that one, we kind of addressed that one while you were getting the other presentation up. So yeah, you could, if, for example, a thermocouple, if you wanted to not go IS, and you could use an IECEX flameproof enclosure and put that thermocouple or RTD in that enclosure and away you go, or you could use a non-certified enclosure, treat it as a simple device, and you're using an intrinsically safe barrier in conjunction with that. So yeah, either choice, either way. And Dirk, I know you said you couldn't see us, and I apologize. I don't know if you're still there or not, but definitely apologize the fact that we weren't able to. Well, I don't know if you're there or not, but anyway, if we didn't answer your question, and you do have some questions that would like to be answered, again, just reach out to us later on, or certainly post it now, and we'll go from there. I know, Gabriella, you're ready to go home, so.
Yeah, almost.
So, well, thank you very much, everybody. We really appreciate your time. We appreciate your patience with us getting up and going today. And again, we hopefully you learned a little bit about some of the issues that maybe you hadn't thought of with regards to some of the EX installations that are out there. And again, you may run into different installations or different requirements or different mistakes, but these are the ones that hopefully I've seen over the years that hopefully will kind of, you can always learn from other people's mistakes, right? So that's what I want to try to do, is make sure that, we learn from other people's mistakes.
Okay, so thank you, Bob, for sharing your knowledge. Thank
you bet.
And yeah, we'll see each other again next time, probably.
All right. Well, sounds great. And enjoy your evening. And I'll enjoy the rest of my day. And for all of you who are still with us, enjoy your evening or morning or afternoon or whatever it is, wherever you're at. Be safe out there. Be safe.
Bye.
Okay. Bye-bye.
Bye-bye.